Okay, today I want to talk about the review for limits, L'Hopital's rule, relative rates of growth, and sequences today. So how to solve limit problems. So first one, use the graphs. So you need to memorize these graphs. So logarithmic graph, the exponential graph, the inverse trig function graphs. So first one, this is y equals ln of x. So we have this graph. Would you like to limit ln of x as x value approaches infinity? What is the answer? What is the limit of ln of x as x approaches infinity? So what's that? Answer is means that the infinity is right. Yes, answer is infinity. Because here x value approach positive infinity. This x value approach positive infinity was ln function. ln function is going up, going to the positive infinity. So next one, would you like to limit of ln of x as x value approaches 0 from the right? So what is the answer? Answer is 1. The 1 is right. So what do you think? Is 1? Kevin said 1. Is 1? No. 0. 0. So minus infinity? Yes, minus infinity. Here, x value approaches 0 from the right. So this x is like x-axis. X value approaches 0 from the right. What happens? ln function. ln function is going down, going to the, yes, negative infinity. Answer is minus infinity. This is like idea. This is the first graph. Second graph, the y equals e to the x, exponential function. Would you like to limit e to the x as x value approaches minus infinity? What is the answer? The 0. Is it right? 0. 0. So 0. Here, x value approaches minus infinity. So what does it mean? X value approaches minus infinity. So like this. So what happens? Exponential function. Exponential function approaches to x-axis like 0. Yes, answer is 0. Limit of e to the x is here. X value approaches positive infinity. So here, yes, you're right. E to the x approaches going up, going to the positive infinity. Answer is infinity. It's like answer. The next one. This graph is inverse tangent of x. This graph is inverse tangent of x. In other words, arctangent. Arctangent of x. The graph of this one. So would you like to limit inverse tangent of x as x value approaches minus infinity? So what is the answer? Yep. X value approaches, you're right, the minus pi of 2. X value approaches minus infinity. Here, approaching minus infinity. What is the inverse tangent function? Inverse tangent function approaches to this dotted line. This dotted line is negative pi of 2. So minus pi of 2. So like this. The similarly, inverse tangent of x as x value approaches positive infinity. The answer is, yep, pi of 2. X value approaches infinity. So what happens? Inverse tangent of x approaches to this dotted line. We have pi of 2. Answer is pi of 2. So like this. So we have another method is L'Hopital's rule. What is L'Hopital's rule? Suppose limit of f of x over g of x as x value approaches a. We have 0 of 0 form or infinity over infinity form. How can you calculate? Like this. Limit of f of x over g of x as x value approaches a is limit of f prime of x over g prime of x as x value approaches a. This is like a whole idea. If the limit on the right hand side exists, this is the important thing, over infinity over negative infinity. So limit of f of x times g of x, we have indeterminate form, 0 times infinity. So this infinity include positive infinity or negative infinity. Either one is fine. The limit of f of x minus g of x is infinity minus infinity. The limit of f of x to the g of x, we have 3 indeterminate forms. 1 to infinity, 0 to 0, infinity to 0. We have 3 indeterminate form. How can solve? Convert them to the quotient form and then use L'Hopital's rule. What's like a quotient form? Because the quotient form is like a fraction. You can change it to the fraction. Next, you have to use L'Hopital's rule. This is the idea. Note, limit of 1 plus a of x to the power bx as x approaches infinity, e to the a times b. Limit of 1 plus ax to the b over x as x value approaches 0, e to the a times b. We have two things. The next one, limit of f of x over g of x is infinity over infinity form. The one more important thing is x value approaches to the positive infinity. So how can you find? So we use relative rate of growth, the next one. Do you remember this one? The one example is limit x value approaches positive infinity, the e to the x over x to the 100. What is the answer? What is the answer? Answer is, what is the answer of this question? Infinity, is it right? Infinity. So I'm going to use this relative rate of growth, this table. The e to the x is here, e to the x. The x to 100 is here. So which one is growing faster? E to the x is growing faster than x to 100. Answer is infinity. The opposite, the limit x value approaches infinity, x to the 100 over e to the x is opposite, going to 0. The bottom one is growing faster than top one, 0. We have either one. These are two answers. So we try to solve this problem. The first one, here, I'm going to use graph of e to the x. Graph of e to the x. The first one, x value approaches 5 from the right. What happens? Exponent 1 plus x over 5 minus x. What's that? X value approaches 5 from the right. What is 1 plus x over 5 minus x? Approach to minus infinity. So you can check. You can plug this value of 5 into x. X exactly 1 plus 5 over 5 minus 5. Exactly 6 over 0 form. This is like a one-sided limit. We have two possible answers, infinity or negative infinity. So which one? We can use one-sided limit here. This is like a 5. The x value approaches 5 from the right. X value approaches 5 from the right. I want to choose test number 5.1. The 5.1 is very close to 5 and greater than 5. You plug 5.1 into x. You plug 5.1 into x. The 5 minus 5.1 is the negative 0.1. What does it mean? This is negative. Was it like top one? Top one is positive. Answer is negative infinity. So we have negative infinity. This is like idea. So what happens? Exponential function here. The exponent approach to minus infinity. Yeah, you're right. The 0. The exponent approaches negative infinity. What happens? Exponential function. The exponential function is the red curve. The red curve approaches to 0. So this is approach 0. Yeah, this is like whole idea. You're right. This is 0. So this is the answer. Second one, how can you solve? So in this case, you can combine difference. Do you know this one? The ln of x minus ln of y is ln of x over y. You can combine two fraction. So you can use relative rate of growth. Top one is infinity. Bottom one is infinity. So infinity over infinity form. X value approaching infinity, what's that? You have to ignore lower terms. So like this, cross out x. Answer is ln of 2/3. This is the whole idea. The next problem. This is like ln function. So we can use graph of ln. So same, x value approaches 6 from the right. What happens inside one? X squared minus 36 approaches 2. So what is the answer? Infinity. Infinity. So you can plug 6 into here. So what's that? 6 squared negative 36 equals 36 minus 36 equals 0. Yes, exactly 0 from the right. What happens to ln function? The inside one approaches to 0 from the right. The inside one approaches to 0 from the right. What happens to ln function? Yes, negative infinity approaches to the negative infinity. This is the whole idea. This is the answer. The second one, you can draw arctangent. This is like a graph. So x value approaches 0 from the right. What happens? ln function. ln function is here. X value approaches 0 from the right. So like this. ln function approaches, yes, negative infinity. Going to negative infinity. You can use previous one. This is negative infinity. So like this. So inside one approaches to negative infinity. Answer is yes, negative pi over 2. Inside one approaches to negative infinity. What happens? Arctangent. Arctangent approaches to this one, the negative pi over 2. So like this. So this is answer. The next one, limit x minus ln of x plus 1 over 1 minus cosine pi x. So you can check. You can plug 0 into x. So we have 0 minus ln of 1. This is minus ln of 1 over 1 minus cosine of 0. What is ln of 1? ln of 1 is, what's ln of 1? Yep, this is going to 0. So top one is like 0. What's cosine of 0? Cosine of 0 is, 1. 1 minus 1. So we have, you're right, 0 of 0 form. So we have 0 of 0 form. So what's that? Indeterminate form of type 0 of 0. So use the L'Hopital's rule. This is like an idea. So this is like L'Hopital's rule. So here you can take derivative. So what's that? This is the same to limit. X value approaches 0. Exactly x prime minus ln x plus 1 prime over 1 prime minus cosine pi x prime. So like this, right? So what is x prime? Yes, 1 minus. What is ln of x plus 1 prime? We can use this rule. You're right. ln of the g of x prime is g prime of x over g of x. So we have x plus 1 prime over x plus 1. This is like this one over What's 1 prime? 1 prime is yep, 0 minus cosine pi x prime is the cosine prime is negative sine pi x times pi x prime, right? This is the idea. The 1 minus x plus 1 prime over x plus 1. So this is same to, we can keep limit, sorry, this is limit, x value approaches 0. So same to limit, x value approaches 0. The 1 minus x plus 1 prime is 1 over x plus 1 over. This is like negative negative is positive. Sine pi x times this pi x prime is just pi. The move to the front, we have it. This is like idea. Like this, so we have it. This one. The next tip, you can plug 0 into x again. So what happens? 1 minus 1 over 0 plus 1 over pi times sine of pi times 0. So what happens? 1 minus 1 over pi times sine of 0. So what's like a numerator? 1 minus 1 is 0. What is sine of 0? Do you know what is sine of 0? Sine of 0 is, yep, this is 0. So we have 0 of 0 form. We can use L'Hopital's rule again. So you can use L'Hopital's rule again. Here. So we have this one. 1 prime is 0. The negative 1 over x plus 1 prime, you can use quotient rule. Keep negative sign. The top on 1 prime times bottom on x plus 1 minus 1 times bottom on x plus 1 prime over x plus 1 square over. The pi sine pi x prime is pi is constant, take out. Sine prime is cosine pi x, inner function pi x prime. So simplify. The 1 prime is 0. This is 0. The remaining thing is, this is the same to what? The negative, the minus 1 times x plus 1 prime is just 1 over x plus 1 square. You can change it positive. So we have 1 over x plus 1 square. The bottom one, the pi x prime is just pi. Pi times pi is pi square. So we have pi square cosine pi x. The next, only plug 0 into x. What's it like a numerator? The 1 over 1 square over pi times cosine of 0. The 1 over 1 square is 1. What's the cosine of 0? Cosine of 0 is, what's the cosine of 0? The cosine of 0 is, yep, this is 1. Final answer is 1 over pi. This is the final answer. So like this, right? The 1 over pi squared. The next tip. So let me see. So what's that? X value approaching infinity. What's the numerator? What's the denominator? So exactly infinity over infinity. So indeterminate form, use relative rate of growth. You can use it. So relative rate of growth. How can you use? Here, this one. The first one. So this is a power genetic. You can change it. This one to the 2 square to the power x exactly 4 to pi x. 4 to x. What's 10 to the minus x? Same to 1 over 10 to the power x. You can change. So like this. Next one. X value approach infinity, what happens to 1 over 10x? 1 over 10 to the x approaches 0. The next, we have three things. Here, 3 to the x is here. 3 to the power x. The 4 to the power x is here. ln of x to 1000 is here. ln of x to the power 1000. You can use relative rate of growth, which is growing faster. The 4 to the x is growing faster. You have to ignore slow ones. Slow ones. The bottom one. Bottom one has here. This is e to the x. Was it like e? The e is the 2.718, the less than 4. The 4 to the x is growing faster than e to the x. X to 200 is here. X to 200, we have this inequality. The 4 to the x is fastest one. You have to ignore slow one. So like this. You can choose 4 to the x and 4 to the x. This is idea. So like this. So next answer is 1. So that's it. This is the whole idea for solving this problem. Number 9. The cosecant x minus cotangent x, x value approaches 0 from the right. What's that? X value approaches 0 from the right. Cosecant x minus cotangent x is, I'm going to change it to the sine and cosine. Yes, constant grows slow. You're right. So cosecant x is 1 over sine x minus cosine x over sine x. So what happens here? What's the graph of sine? The graph of sine is like this, sine of x. X value approaches 0 from the right. Sine function is above x-axis. 1 is positive, sine is positive. This is infinity. Was it like here? The same. This is positive. You plug 0 into here. The cosine of 0 is positive 1. So we have positive or positive infinity. Exactly infinity minus infinity. So how can we solve? We can convert this one to the quotient form and then use a L'Hopital's rule. This is the whole idea. How can you change it? You can use the identity. Cosecant x is 1 over sine. Cotangent of x is cosine of sine. The combine. So you can plug 0 into top one and bottom one. What happens? 1 minus cosine of 0 over sine of 0. So we have 1 minus 1 over 0 is 0 of 0 form. What's like next step? You can use L'Hopital's rule. This is idea. The L'Hopital's rule. The 1 prime is 0. Cosine prime is negative sine. The negative cosine prime is sine. Sine prime is cosine. The next, you can plug 0 into x. You plug 0 into x. So what is the answer? Sine of 0 over cosine of 0. Sine of 0 is 0. Cosine of 0 is 1. Final answer is 0. This is the whole idea for solving this problem. Like this. Next one. The x value approaches 2 from the right. You can plug 2 into here. What happens to x minus 2? This value approaches 0. What's ln function? You can draw graph of ln. The graph of ln is like this. What is like ln of x minus 2? So x minus 2 approaches 0, is right? Because x value approaches 2. So inside one approaches 0 was ln function going to minus infinity. This approach is minus infinity. So what does it mean? This is going to minus infinity. Exactly 0 times infinity form. 0 times infinity form. So we have like this. So same, convert this one to the quotient form and then use L'Hopital's rule. So we have two possibilities. You can change it like this one. ln of x minus 2 is numerator. x minus 2 is going to denominator by using reciprocal. This is one possibility. The another possibility is x minus 2 is numerator. ln function is going to denominator, ln of x minus 2. So which one is better? The first one or second one? Which one? The first one, second one. So Kylie said it's the first one. Is it right? The first one? Yes. We have ln function. What's the best way? ln function is top. The polynomial is going to denominator. This is better. You can change it like this. Next, you have to use L'Hopital's rule. So what's that? Here, this is a limit. X value approaches 2 from the right. ln of x minus 2 prime is x minus 2 prime over x minus 2 over. What is 1 over x minus 2 prime here? The 1 over x minus 2 prime is, you can use a quotient rule, 1 prime times x minus 2 minus 1 times x minus 2 prime over x minus 2 squared. The 1 prime is 0. The x minus 2 prime is just 1. The minus 1 times 1 is negative 1 over x minus 2 squared. So this is what? Here. Negative 1 over x minus 2 squared. So what happens? This is same to limit. X value approaches 2 from the right. Top one is x minus 2 prime is 1 over x minus 2 over minus 1 over x minus 2 square. You can change this complex fraction to the simple fraction. Limit x value approaches 2 from the right. Numerator is 1 over x minus 2 times the reciprocal of denominator, the x minus 2 square over minus 1. So what's like the next step? This is the same to this one. X minus 2 is crossed out, just x minus 2 over minus 1. You plug, this is positive, 2 from the right. You plug 2 into x, we have 2 minus 2 over minus 1 is 0 over minus 1, answer is 0. This is like a whole idea for solving this problem. So like this. Here. The next thing. So what's that? X value approaching infinity, so what happens? This x value inside one approaches infinity. Was like 1 over x, 1 over infinity is 0. We have infinity to the 0 form. This is indeterminate form. So how can solve? Step 1. Take ln. X to 1 over x. Power 1 over x is like down. 1 over x times ln of x because 1 over x is down. So like this. The next, take limit. X value approaches infinity. So same to limit x value approaches infinity. ln of x over x. So what is the answer? So what is the answer? Answer is, do you know what's ln of x over x? So here, x value approaching infinity, you can plug infinity into top one and bottom one. Top one is infinity, bottom is like infinity. So one method is relative rate of growth. Yes, infinity with infinity. So which one is growing faster? X is growing faster than ln of x. So answer is 0. This is one method. Another method is you can use L'Hopital's rule. This is another possibility. So ln of x prime over x prime. Same to limit x value approaches infinity. The ln of x prime is 1 over x prime is 1. We have limit x value approaches infinity, the 1 over x. So 0. The 이동 is fine, like 0. So I want to use relative rate of growth. This is very easiest way, I think. Step 3, take what? E. Because you can eliminate ln, take e to the zeros, right? Take e, the both sides, e and e. So like this. So ln and e canceled. This is like idea. So we have e to the 0. E to the 0 is 1. This is like 1. This is your final answer. How to check if a sequence converges or diverges? How can check? We can use one theorem. The limit of f of x as x value approaches infinity equal to L. So f of n equals an. So n is an integer. The limit of an is going to same number L. This is very clear. I want to give one example. So limit x value approaches infinity, the 1 over x. Answer is 1. You can replace x by n. X by n. Oh, sorry, the 0, not 1. The 0. This is also same number 0, just like exactly. This one. The limit laws of sequence. The sequence an, sequence bn are convergent sequences, and c is a constant. As like limit of an plus bn, distribute limit. The limit of an minus bn, same, distribute limit. Limit of an minus limit of bn. The limit of c times an, you can take out c. Just take out c. So one possibility. The limit of c is, what's the limit of c? What's the limit of c? Do you know limit of c? Yes, c. Same number. Limit of an times bn, same. Distribute limit. Limit of an times limit of bn. Limit of an over bn. So same. Distribute limit to the top and the bottom one. In this case, we have the one restriction. Limit of bottom one is non-zero. So we have this restriction. Limit of an to the power p. The limit is going to inside 1. Limit of an to the power p. If p is positive, an is positive. Sometimes we use squeeze theorem. The Bn is between an and cn for n is greater than or equal to n0. Limit of an, limit of cn is like L. So limit of Bn is also going to L. This is a theorem. Limit of absolute value of n is 0. Automatically, limit of an equal to 0. This is squeeze theorem. I'm going to give it one example. So do you know this one? Limit of n approaching infinity, sine of n over n. What is the answer? What is the answer? Answer is 1. What do you think? 1? Is 1? So 0. Yeah, because really be careful. The limit of x value approaches 0. Sine of x over x. You can use L'Hopital's rule. This is 1. This is 1. Here we can use squeeze theorem. Sine of n is between -1 and 1. So like this. Divided by n. Take limit. Take limit. The take limit. Left hand side going to 0. The right hand side is going to 0. This one is going to same number 0. That's it. This is 0. Similarly, limit of n approaching infinity, the cosine of n over n is also 0. We have the same reason. So one example, the limit n approaching infinity, the 5n plus sine of n over 2n plus 1. What is the answer? What is the answer? What is the answer? What is the limit of 5n plus sine of n over 2n plus 1 as n approaches infinity? How can you solve? Here. This is exactly infinity over infinity form. What's the best way? So we have this kind of things with the sine and cosine function. You always divide top and bottom by highest power in the bottom one, like this. So what happens? Limit n approach infinity. So you can distribute 1 over n to the first and second one. N is crossed out 5 plus sine of n over n over distribute 1 over n to the bottom one, 2 plus 1 over n. What happens? N is going to infinity. Sine of n over n is going to 0 by using squeeze theorem. So 1 over n is going to 0. What's your final answer? 5 over 2. This is idea by using squeeze theorem. You got it? This is idea for using squeeze theorem. So next one, indeterminate form or L'Hopital's rule. So limit of an over bn is infinity over infinity, 0 of 0 form. You can use L'Hopital's rule. So limit of an times bn is 0 times infinity. The an minus bn is infinity minus infinity. An to the power bn, 1 to infinity, 0 to 0, infinity to 0. Convert them to the quotient form and then use L'Hopital's rule. You see, like another way. So similarly, limit of 1 plus a over n to the power bn as n approaches infinity, answer is e to the ab. Was it like a relative rate of growth? So similar, only difference is n factorial is here. The one example, the limit n approaches infinity. So n factorial plus 5 to the n plus n to the 100 over the 7 to the power n plus n to the 1000 plus 5. What is the answer? So what is the answer? The answer is infinity, infinity, infinity. Yup, here. You think about n factorial. This is n factorial is here. The 5 to the n here. So this is greater. So n to the 1000 is like a top, n to the 100 here. So fastest one is n factorial, ignore slow one, same. 7 to the power n is here, 7 to the power n to the 1000 is here. The 7 to the n is growing faster than n to the 1000. You have to ignore slow one and the constant. We have limit n approach infinity, n factorial over 7 to the power n. You can compare. N factorial is growing faster than 7 to the power n. So we always growing faster than n factorial. Answer is infinity. Yeah, this is the whole idea by using relative rate of growth. Determine whether 1 plus 2 of n, level 3n converges or diverges. What is the answer? Converges or diverges. What do you think? Yes, converge to the e to the negative 6. Here, this is what? Calculate limit. Was it like 2? A is 2. Was B? Negative 3. B is negative 3. You can plug 2 times negative 3. So we have it. Answer is e to negative 6, 1 over e to the 6. Converge to 1 over e to the 6. That's it. It's a sequence problem. The next one, determine whether two sequences are convergent or divergent. How can you solve? You can take a limit. You can use this one. The first one, take absolute value 1. So we have it. Yep. So we have used relative rate of growth. You have to ignore lower terms like this, cross out and square. So we have 0. The bottom one is growing faster than top one, answer is 0. So absolute value 1 is approach 0. What happens to original one? Original one approaches 0. So that's it. This is the whole idea. And second one. What's the second one? Diverge. We think about it. Just only here, this one. The limit of positive 1, same. Ignore lower terms, cross out and cube, answer is 1. So we have it. This is the approach 1? No. What's the original one? The original one is take minus 1 to power n. So what happens? You can draw the graph. So what happens? This one. N is even power, so this is a positive. N is odd power, negative number, so like this one. What happens? Even things approach to 1. Odd powers approach to negative 1. What's that? Oscillating. Oscillating infinitely many times, so does not exist. So diverges. This is idea for solving these two kind of problems. So what does it mean the first one? This is the first one is different. Approach what? 0. Yes, 0. Because in this case, similar. This is so positive 1 approach 0. You can take a negative 1 to n. What happens? So negative, positive, negative, positive, but approach 0. What happens? Even 1 approach 0. Odd 1 approach, same number, 0. So approach 0. So we have 0. This is totally different. So positive 1 approach 0, answer is 0. Positive 1 is going to non-zero number, always oscillating, divergent. Yep, this is like idea. It's good? Okay, next one. Determine whether 4 minus pi to the power n factorial plus a to the n plus 5 over 100 didn't disappear with the second one. So, okay. So second one, yeah, not the disappeared. You can take absolute value, same thing. So my point is like approach 1, you can take minus 1 to n, that does not exist. So here, positive 1 is going to 0. Take minus 1 to power n, this is going to same number 0. This is totally different. Does that make sense? Explain it later. So here, determine the whether the 4 minus pi to the power n factorial plus a to the power n plus 5, 100 to the n plus ln of n, 1000 plus n to the 100 plus 2. So here, what's like a 4 minus pi? The 4 minus 3.14 is 0.86, right? This is less than 1. So what's it like a limit? What's the limit? What's the answer? Going to 0. Right? Because, so this inside of is like a small number, 0.89. This is same to limit n approach infinity. Here, 0.86 to the power n. So was it like 0.86 to the power n? You can just sketch the graph. Graph is like this. The 0.86 to the power n. The n is going to infinity. This graph approaches 0. So we have this answer. So next one. Was it like a relative rate of growth? So we use it. So second one, here. What's that? N factorial is here. N factorial. A to the power n is here. This is growing faster one. Ignore slow one. Next one, 100 power n. Ln function is here. So n to the 100 is here. So we have n to the 100 slower, ln of n to the 1000. This is like the fastest one. You have to ignore slow one. So we can choose n factorial over 100 to the power n. So like this, same. N factorial is growing faster than 100 to the power n, going to infinity. So the sequence is divergent. That's good. So this is all for today's lecture. So do you have any question? So if you have any question, I will explain the more things. So thank you all of guys. So you can explain on the chatting board. Thanks. I just waiting your question. If you have any question, you can write. I will answer your question.